Okay, so we're ready to get started. We're going to be working on the simplifying of radicals. So we're going to start with number 15. And remember, when we simplify radicals, we need to try to find a perfect square. In this case, this is a square root, and understood 2 there. So I want a perfect square that is in 27. So I'm going to come over here and I'm going to do my factor tree for 27. Well, I know 27 is 3 times 9, and 9 is 3 times 3. So 27 is really 3 times 3 times 3, which if I'm doing a square root, I need a group of 2's. So I have one group of 2's that gets to go out and play, and I get a 3 that doesn't have a group, so it has to stay inside. And so now that is going to be my -7, and then times the 3, and then times the square root of 3. Now I'm going to leave some space here because now I need to do my variables. So when you do variables, again, remember A4 is 4 A's, and that means I have 2 groups of 2 A's. So this may mean I have 2 groups that can come out and play. And if you notice here, there's nothing left over, so there's no A inside. Now, the other way is we've done power over root. And so we know A would be 4 over 2, which is just A squared, okay? And it's the whole number A squared, so that comes out. So B would be the same thing. So I'm going to have 2 B's that come out. Now C has 3 of them. So if I do power over root, let's just do it this way. Well, 3 over 2 is 1, and then it's another 1/2. So that means I have 1 that comes out and 1 that is still under the square root. See how I did that? So this is my whole one that comes out, and this is my square root that stays. Okay. Now the last thing I would need to do would be to combine those two, the 7 and the 3, and I'm going to still have the 3C left over. Okay. 16. Same problem. This time it's 147 xy squared z4. So again, I'm going to come over to the side. I'm going to erase this here, so if you needed to see what's over to the side there, you might want to stop and write it down. Okay, so I'm going to take 147 and I'm going to start breaking it apart. Well, I know 7 will go in there. That will leave me with 21. And 21 is 7 and 3 also. So there's my 3 numbers. So you can see I have a group of 7's that gets to go outside, and a 3 that's by itself that can't go outside. And then I'm going to multiply it by the -6. So here's what I have as of right now. And again, I'm just going to pull my -3 or my 3 over here because I need to work with my variables. Now I have just a single x. That's x to the first, which means there's only 1. You have to have at least 2 before they can go out. So no x's can go out. The other thing would be if I wrote it as a power over root, it would be x to the 1/2, which says the x is still the square root of it. Okay, so that still means the square root of x. Y, so y would be 2 over 2, which is just y1, the whole number, so it gets to come out. Z would be z over 4 over 2, which would be z squared, which gets to come out. So in that case, that's all my answer would be. I just need to go in and simplify these two. Okay, so hopefully you remember all of that. Now 17 is a cube root. So the difference in a cube root and a square root is now everything needs to have groups of 3, not groups of 2. So again, I'm going to get rid of this here just because I need space. So I'm going to start with the 384. And let's see. I'm going to try just 2 because I right off can't tell you what goes in there. So 2 will go into 3 once, 18, 9, and 4 twice. So there's that one. Again, I still have a 2. That would be 9 and 96. And now I've got 8 and 12. I know that. I'm going to have a lot of numbers here. 4 and 2, or I know 2, 2, 2. I'm going to go ahead and do that. And I have 3 times 4. Okay, 3 times 4, and I know 4 is 2 and 2. Okay, so now I'm going to rewrite all this so don't lose anything. I have this 2 up here. I have this 2. I have these 3 2's. I have the 3. I'm going to put that over here, and then I have the other 2 2's. Okay, so I need groups of 3 though, not 2. So I have one group of 3, another group of 3. So I have 2 groups of 3. I'm running out of space. So that would mean that I take out 1 2, one group of 2's, another group of 2's. The 2 and the 3 don't have any partners, so they're going to stay. So this is really, I'm going to slide this up. This is really 4 square root of 6. Now do you see where I got all that? I prime factored it, and since I am looking for cube roots, I need 3. So that's one group of 3 that comes out as a 2. I have another group of 3's that comes out as a 2. Now if I'm doing this as my power over root, it would be this 2 would say I have 3 of them, so a power of 3, and I'm taking the cube root of it. See, that's why I have a 1. Okay, so 4 square root of 6, and then again I have the 7 out in front. Those multiply together. I'm going to put the cube root of 6 over here. Put that cube root. That was a cube also up there. Now I'm going to do my variables. So I have 7 h's. Okay, I'm going to just come over here. So that would be power over root. Wow, wrong thing. Power over root. It's just a third root. And guys, if I change this to a mixed number, it would be 1, actually 2, because I have, it would be 6 and 1/3. So I have 2 h's, and I have 1 left over, that 1 right there. J to the 3rd would be 3 over 3, so J1. K, there's only 1, so it stays. And then I'm going to go ahead and not distribute, but multiply these 2 together. Now, guys, remember, you know, we're reviewing for the test. This is just a review. So if you're not understanding something that I'm doing on one of these reviews, then you might want to come in and get some assistance. Okay, 18. It's back to a square root. Okay, again, this is the number 8. When I factor it, I get 2 and 4, which is 2 and 2. I have, again, it's a square root, so I need one group of 2's and 1 left over. So 3 times the 1 group, 1 left over. P3 would mean divide by 2, so that would be 1 with 1 left over. That's how I think of it. R3 would be 1 and 1 left over. So basically this is always your leftovers, okay? And the final step would be to take the 2 times the 3 and final answer. Okay, that is the square root stuff.